Hello. Good day everyone. I'm Jerzen. Welcome back to this channel. This next repair is in a Marflex microwave oven, model F20D. The customer said, this oven sparks itself. And smoked inside. I'll show you how to fix it. If you like electronics and want also to learn about repairing, you can found some ideas on my video, so don't forget to subscribe on my channel to update on my next video. So let's get started. Since the customer said that this microwave sparked and smoked, and the microwave still have a power, let's check first the actual running current. I measured 2.9 amperes on actual running current. Let's check the maximum energy consumption on nameplate. The nameplate is located at the back of this unit. The nameplate is almost tampered. The maximum energy consumption indicated on nameplate is 1050 watts. Our 2.9 running current is not passed on this 1050 maximum energy consumption, because our power is in between 220 to 230 volts AC. Because current is equal to unit of power, divided by power, based on Andre Marie Ampere law, so it must have 4 to 5 amperes, but we only measured 2.9 amperes only. Since we diagnosed that the current has failed, let's now proceed to check the temperature inside the microwave. Now let's put this glass inside the microwave and test if the temperature is rising. But before we put this glass of water for testing, let's measure first the actual temperature of this glass. The 31 degrees Celsius displayed on our digital multimeter is our ambient temperature. And the actual glass temperature is 29 degrees Celsius. A device called a magnetron inside the oven produces microwaves. The microwaves reflect off the metal interior of the oven, and cause the water molecules in food to vibrate. This vibration results in friction between molecules, which produces heat that cooks the food. Now let's put this glass inside the microwave oven and let's program the oven into 4 minutes express cooking.
A few moments later.
After 1 minute of express cooking, let's stop the express cooking and check if the temperature of the glass we put inside has risen. I measured 28 degrees Celsius, the temperature is the same as before. If the microwave isn't heating food, it's likely that the magnetron inside is broken. Unfortunately, a burned out magnetron can't be repaired, it has to be replaced. Other issues that can lead to food not being heated includes a broken diode or a faulty door switch. Now let's disassemble the back cover of this microwave oven, and let's check the component parts inside if they are working good. After removing the cover, we can visualize the interesting parts inside. This is the magnetron that generates microwaves. This transformer is responsible for converting the electricity into much higher voltage. An automatic fan that help control the excess heat. A tuning element, low capacitance value, used as a DC block for RF signal sees a low impedance. Now let's proceed to troubleshooting. Using analog multimeter, let's check first the continuity of the thermostat. The continuity of thermostat is good. Let's check later if the thermostat is gauging the proper temperature. Since the microwave has a power, let's assume that the main fuse is good. Now let's check the transformer. This transformer has 3 windings. Let's check first the primary windings. It must have 2.5 ohms to 5 ohms resistance. We need to disconnect the connections before testing the resistance for proper reading. The pointing needle of our multimeter pointed into 0 ohms, but I disregarded it, because I ranged the range selector into X10 range. Now let's check the secondary low voltage windings. It must have less than 1 ohm. The beginning and the ending of this wires are both connected on this magnetron pins. For heating magnetron filament, this coil generates a low voltage output. Since this winding resistance is below 1 ohm, let's consider the reading of our analog multimeter as good. Now let's check the magnetron filament. The resistance of this filament is below 1 ohm also. Since this winding resistance is below 1 ohm, let's consider the reading of our analog multimeter as good. Because I range my multimeter into times 10, because my times 1 range is faulty. Now let's check the third windings of this transformer. This third windings is for the ground connection and has a high voltage. The high voltage of this windings provides between 1800 to 2800 volts. Not much high. But always treat them with utmost respect. If not, it may stop your heart beating, and only God gives second chance if you make a mistake. The ending of this high voltage winding is connected on the ground of the microwave, and the beginning winding is connected to capacitor. It is the ungrounded terminal, and the diode's ring terminal grounds the appliance frame. It must have a resistance of 150 to 300 ohms. But I measured no continuity on it. Now let's check the high voltage fuse mounted on this high voltage winding. Let's open the high voltage fuse holder. The high voltage fuse is disconnected. The most common reason why these fuses are blown is leaked capacitor, faulty diode, or grounded transformer, or sometimes the failed magnetron. Now let's try to reconnect this high voltage fuse and test the running current. Now the high voltage fuse reconnected, let's put back the fuse holder. Now the fuse holder already holds the fuse. Let's try to measure the resistance of this high voltage winding. It must have 160 to 300 ohms. Once it drops below 160, the windings must have shorted. By the way, this capacitor on a microwave can hold 4000 to 6000 volts unplugged. It takes a weeks or even months before it discharges. Make sure to discharge it before testing. Many technicians have died from that capacitor than anything else. I measured almost 200 ohms on my multimeter. Let's try the digital. I measured 196 ohms from the digital, and it is good. Now let's try to plug the unit and check the total current when it's running. The maximum total energy of this microwave is 1050 watts, and our power is 220 volts. If we divide 1050 into 220, we have a total of 4.7 amperes, almost 5 amperes. If we get more than 9 amperes, the problem is in the high voltage circuit. My guess would be a bad transformer or magnetron. Let's put also a glass of water inside the microwave for testing, and let's measure first the glass temperature. The glass temperature is 29 degrees Celsius. Let's put this glass inside the microwave for testing. Now let's turn on the unit and let's measure the total running current. I am scared to see a fireworks this time, because the Christmas season is not yet on the air, and the Second World War is already finished. No, I am not joking, the Second World War is already finished. Since our clamp meter already clamped, let's program the microwave into 4 minutes express cooking, and let's see the total running current. I measured 5.18 amperes on total running current, and the current is pretty good. Now let's observe the unit. While observing, let's find a fireworks. Seems look like the fireworks has expired. The running current is stabilized into 5.13 amperes, and it is good. It was almost 1 minute. Now let's stop the program and test the bottle we put inside if the temperature is rising. The temperature of the bottle rised by 13 degrees Celsius. It means the unit is now good and the current is pretty good. A microwave is a very high power, high frequency electromagnetic waves inside the oven cavity, and the power can fried you in a microseconds. Maybe the customer did not notice that they put an iron inside the oven cavity, caused the oven sparked itself and smoked inside, and caused the high voltage fuse open. Seems okay now. If you found this video is useful, please support by hitting the subscribe button and click the notification bell to update on my next video. Once again, I am Jerzen. Bye for now.